Okay, so today I'm going to be talking about the basic biomechanics and anatomy of the ankle joint. So let's start by explaining the ankle joint, the bones that are involved, and some of the basic motions. So in order to envision and orient yourself, let's imagine that you're standing and your friend is standing right in front of you and you're looking at their right ankle. That's kind of the orientation of this photo. So your friend's standing right in front of you, you're looking directly at their right ankle, and on the inner side of the right ankle, you're going to notice a big bump, and that's going to be called the medial malleolus. And if you look from the outer side of their right ankle, you're going to notice another bump, and that's going to be called the lateral malleolus. Now, the medial malleolus and lateral malleolus are going to be attached to two different bones. So the tibia, which is going to be the main portion of our shin bone, is going to extend downward, and this part, that bump on the inner side, is going to be called the medial malleolus of the tibia. And on the other side, the lateral malleolus is going to be that bump all the way at the bottom of their ankle, and that's going to be part of the fibula. Now, the fibula and tibia are connected to each other by something called the interosseous membrane, and that's going to be known as a syndesmosis joint, which basically means that there's very little movement between the tibia and the fibula. Now, if you look at this bone, the one I'm outlining here, so all the way from here down to there and around, this is going to be called the talus. And the talus is the main bone in our foot that allows our ankle to move up and down. So this entire structure is going to be called the talus. And the talus is going to articulate or connect to the fibula and the tibia near the medial malleolus and lateral malleolus. So basically, this whole area right here that I'm outlining is going to form that ankle joint that allows us to point our toes to the sky towards our shin and allows us to point our toes downward. Now, the ankle mortise joint, which is basically what this whole thing is called, is going to be a hinge or ginglymoid type of joint. And what that means is it's going to move on a single axis, and its main motions are going to be in dorsiflexion and plantarflexion. So like I said before, the talus right over here with the tibia and the fibula is going to move up and down. And when you point your toes up towards your shin, towards the sky, that's going to be called dorsiflexion. And when you point your toes downward, like a ballerina, that's going to be called plantarflexion. And those are the main two motions of the ankle mortise joint. Okay, this is going to be called the dome or the trochlea of the talus. And this area up here at the front is going to be called the neck or the head of the talus. And the neck and the head of the talus over here are going to join with this bone called the navicular. And that's going to be more part of our foot anatomy and biomechanics. So for now, we're only going to focus on this silver part. So right over here, this entire silver part, that's going to be called the dome or the trochlea of the talus. And the dome of the talus is going to be the only part that is going to form our ankle joint. So the head and the neck have nothing to do with ankle biomechanics. We're only going to be talking about the dome over here. And as you notice over here, the dome, the silver part, is the only part that's really joining with the tibia and the fibula to form that ankle joint. And therefore, that's the only part of the talus that we need to think about when it comes to moving our foot up into dorsiflexion and down into plantarflexion. Okay, so in order to understand plantarflexion and dorsiflexion a little bit better, I want you guys to try an experiment with me. And I want you to point your toes to the sky as high as you can, and then try to point a little bit higher. And you might notice that your toes start to point a tiny bit outwards. Now, let's try the same thing but for plantarflexion. So point your toes down as far as you can go, and then try pointing a little bit further down, and you might notice that your toes point a little bit inwards. What that means is that dorsiflexion, pointing our toes upwards, is associated with external rotation, and pointing your toes downwards is associated with a little bit of internal rotation. So why is that? This is kind of the common point of confusion, and many biomechanics texts and videos and lectures often explain it in a way that's confusing if you're not familiar with the anatomy. So let's do this from our perspective. So if we flip over the photo, it's a lot easier to imagine ourselves in the image. So this is going to be our right ankle as we look straight down at it. So remember, the dome of the talus, this silver area, is the only part that's going to join with the tibia and the fibula to form that ankle joint. We're going to ignore the head and the neck of the talus up here. So let's look at the anterior edge of the dome of the talus. Now the anterior edge of the dome of the talus is going to be a little bit longer than the posterior edge of the dome of the talus, right? So the anterior margin over here is going to be a little bit longer than that posterior margin, and it's going to fit straight against the medial wall. So imagine that this is your right ankle. So I'm looking straight down at my own right ankle right now, and I'm pointing my toes straight towards the sky in dorsiflexion. Now, how do I get a little bit of that extra motion? Well, I can't rotate inwards because I'm already all the way against the medial malleolus, that bump on the inner side of the right ankle. But if I want to go a little bit higher, what if I can just turn a bit outwards? Because I have space between the dome of the talus and the lateral malleolus, so that outer bump. So there's space to go a little bit outwards. So I point my toes all the way up, and then I rotate the dome of the talus straight against this edge, I can point my toes outward and get a little bit higher in terms of range of motion. Okay? And now let's do the same thing for plantar flexion. So I'm going to take my right ankle, I'm going to push my toes straight down like a ballerina, and if I want to go a tiny bit further and put my toes a little bit more down, I can actually rotate inwards, right? Because we have space again next to that lateral malleolus. If I point my toes down and want to go a little bit further, I can rotate this posterior part of the dome of the talus until it's all the way against that lateral malleolus, and that'll allow me to point my toes a little bit inward to go a little bit further down.